Okay, welcome everyone. Hope you really enjoyed the gala last night. We thought we'd start today's sessions with a light look at the Internet of Things. As you've seen from the keynotes all around us in the sessions, Salesforce is really promoting the fact that not just humans connect to the Internet anymore, it's now machines and devices which help us move through our daily lives with a little bit more ease. So this is a kind of session that helps us appreciate exactly what's involved in that. If you're sort of looking at these sessions and hearing all about it, thinking, well, how do machines actually connect to the internet? What's involved? What sort of hardware is needed? What sort of software and APIs are needed? Then that was kind of the inspiration for this session, and also the fact that I got to play with Lego as part of my job. So that was a good motivator as well. So I've got a few slides and some demos. We're also doing a bit more of a demonstration, an in-depth look later on this afternoon at 2 p.m. at the Internet of Things zone around there. So I'll be over there for about an hour and a half from 2 p.m. onwards. So my name's Andy Fawcett. I'm Financial Force CTO. I'm responsible for how Financial Force adopts the platform and technical strategy around our applications, best practices. We also work very closely with Salesforce in terms of their pilot programs and giving them feedback and input as to where the platform goes. Financial Force, very briefly, has its headquarters in San Francisco. We're just on Market Street, so very close to Salesforce. We've got offices from an R&D perspective in the UK, Spain, Canada, Manchester. In fact, we've got sales and marketing out of some of those locations, and are also really pleased to be opening an office in Sydney as well later this year. Our growth has been huge over the last 5 years. We celebrated our 5th birthday on just at 30th of September. We're now up to, by the end of the year, 400 employees. So massive growth, lots of customers around the world, as well as employees, as you can see. Our year-on-year revenue is also growing very nicely, and we're very pleased to have received some investment from Advent, and which we're spending wisely. So Financial Force aside, here is some more information you can get about the session. I haven't posted links and things on this. If anybody wants this deck or any links and stuff, I will post this on the chatter post for this session. So make use of the Dreamforce app, go to the session, follow the session. I'll post messages and things and answer questions on there as well. So be sure to check out the session chatter feed. So what we're going to talk about in this session is what the device requirements are, because choosing the device you want to connect to the internet makes a big difference in terms of the technologies and tools that you may be familiar with. If you're familiar with machine code, low-level C programming languages, then there's quite a lot more options for devices you can connect. If you're happy with Java and other higher-level programming languages, then you need to consider more of the device capabilities. That'll drive how intelligent the device needs to be, and also whether or not it can draw some of its intelligence from the cloud, and that's really what we're going to be looking at in this session. These robots are really drones to the cloud. They're taking instructions from the Salesforce cloud. So we'll talk about how we've built a kind of machine cloud within Salesforce1. It's not to suggest that it's a separate cloud, really. It's just really the same cloud you and I are using all the time, but to these guys, it's a place that they can connect and transfer and communicate just as much as we can. We'll do some demos. So I'm really hoping the demos go okay. We've had some great support from Salesforce. We've got John Stevenson down here. Hello. Our cameraman for the day. And we've been provided a very nice Wi-Fi widget, which is hopefully going to mean connectivity remains solid. I've got some notes later on in the deck so you can actually make these robots yourself. Obviously, it's a standard Lego kit. But you will need some extra peripherals to connect them to the internet and run the software. And I will be open sourcing that. So if you wanted to get home and try this out yourselves, then you absolutely can do. So let's just talk very quickly about the type of capabilities that we'll be requiring. Ultimately, most devices will need to talk to the internet one way or another. Some devices will do that by pairing with a PC or a Mac. So they're kind of less autonomous. They will always need that sort of support from a computer running nearby. Moving further down, then you do get devices that have got built-in Wi-Fi adapters so they can connect directly, and these robots are in that category. They'll connect directly to the internet Obviously, we're going through a Wi-Fi hotspot here, but that could equally be the Dreamforce Wi-Fi if it was a little bit more stable. So SSL support is quite important if you're connecting to any cloud services such as Salesforce, so encryption is quite important. That can be quite a heavy task for a device, so the device CPU needs to be quite beefy to support that level of encryption. We're all familiar with JSON and XML, that's the language of the internet pretty much, and having the ability to consume that information one way or another on the device is equally important. When you get down to the bottom there, then the kind of nirvana of support is being able to run Java. And there's a community out there called Legos who've done some great work on these machines to allow us to run Java. And Oracle themselves actually have provided a port of Java to run specifically on these machines. If you Google for Lego and Java, the first hit you'll find is an Oracle website, which kind of stunned me a little bit, you know, but it shows that Oracle is out there helping support community and doing things that prove that their JVM can literally run on any device. So very interesting side project for Oracle to be running. So we're focusing on running Java. Oracle have ported it to the processor that runs on the machine, and that's what their website looks like. So it's a proper Oracle website dedicated to running their JVM on the robots. So the language that they provided is Java, but the library has been developed by an open source community called Legos, and the syntax looks somewhat like this. As you can see, it's pretty straightforward to display things on the screen, move the motors around, that sort of stuff. So we'll have another glimpse at the code a bit later on in the session. So the devices can vary a lot between the processing power and the storage, and it also depends on the type of inputs and outputs you want. You need to make sure that you've got communication via HTTPS, and ideally some way of polling or streaming from the cloud. And I've used the Salesforce streaming API to make these robots respond near real time as possible to commands that are coming from the Salesforce cloud. You could equally use a polling technique, but that's likely to use up batteries and use up resources as it's constantly polling. So if you have a streaming facility, that's much more, much easier for the robots to talk to. These robots will support connections to them locally, so I could actually connect to them and telnet to them. They're running an actual operating system, actually running a version of Linux there. So these are some of the hardware specifications. It has got an ARM processor in there, quite a bit of memory. The Wi-Fi support is supported as long as you plug a dongle in the side of it. It doesn't come built in, and there's some Bluetooth support. So actually some pretty meaty hardware inside what is effectively a toy, a Lego brick. So what makes a machine cloud? Well, the machine cloud is a single place to communicate and share information, just like us as human beings are finding value in Salesforce, sharing information, data, connecting our customers and ourselves together. And so can be the same for machines. Machines can communicate with us as well as each other, which is also good. We can see that jet engines these days are using Salesforce to relay information and dump that into Salesforce so the engineers can walk up with their PDAs or tablets and see what the diagnostics are. So they're communicating that information. Information can be stored. Often the storage mechanisms are limited on the devices. And also you probably don't want to risk sensitive information sitting on the device too long. So pushing it out into some kind of machine cloud is going to be preferable. You can also perform calculations on the devices. Now, of course, the devices are clever enough to make calculations themselves at a local level, but if they want to combine information from other devices, then it's better to make those calculations in the cloud and simply then instruct the robot or the device what to do. So you can leverage the power of computational information inside the cloud using a machine cloud. So let's think about how we build a machine cloud in Salesforce. So Salesforce really allows us to create a place to store that information readily using custom objects. No coding required, point and click development, create some custom objects. We then need to connect to Salesforce, and Salesforce has done a great job at creating a connection facility called Connected Apps. It's what Salesforce1 uses. When you build a mobile application using Salesforce, you create a connected app. and it gives you quite a lot of facilities for security and sending messages to devices. We're going to need to use some APIs, so the REST APIs and the streaming APIs are really important. We're going to need to communicate with Salesforce. And Salesforce1 Mobile actually could be used to control these robots equally. I'm going to use the Salesforce desktop UI. It's a little bit easier for us to see on the big screen, but I could equally be using Salesforce1 Mobile to control these because, of course, it's using custom objects. They just simply surface in there. So I've created a custom object model, and this is what it looks like. I have a robot object, so we can have multiple robots in our machine cloud. It'd be a pretty lonely cloud with just one robot in it. We can have a command object, and we'll see how we can control the robots by sending records and creating records inside that command object. And so that we could send multiple commands at once, we can create a program and list those commands in sequence. Not demonstrating today, but there is a sensor data object that I've created so we can capture information back into Salesforce and maybe do some analysis on that. So here's a brief screenshot of what the command object, the robot object, looks like. In Salesforce1, it's pretty good UI out of the box. I didn't create that UI. Salesforce1 Mobile simply presented that because it looked at the object that I created, and I got the drop-down for the type of command just displayed there. In the Salesforce desktop UI on the far right, you can see it's a similar type of data entry. So that's what controlling these robots looks like. The aim really for this project was make it clicks, not code. Wanted to allow people, once you've set the software up on the devices and installed the package, to actually enjoy using robots and controlling them by just simply using Salesforce. That was kind of one of the big goals behind the project, is to allow non-technical people to be able to do this. So the first demo I'd like to show you is the ability to pair the robots together, because one of the downsides of a lot of devices is, of course, they're not great on user input. There's no big keyboard, there's no screen. Obviously, the devices are typically very small. So I wanted to create a way that we could sign into Salesforce without having to go through the whole sort of entering my password. The screen's very small, kind of microsurgery system. So I've decided to leverage a technique that I see, all of us see every day with Bluetooth. You kind of see a PIN number, you type it in, and you pair the devices together. So it is really just a prototype. I've definitely not given this complete thought in terms of security, and all aspects of it is just a bit of a fun project at the end of the day. But it seems to work pretty well for this use case. So what I've got over here is one of the Lego robots on the stage. From your point of view, it's the one on the left. And it's running, I'll just pick it up here. You can actually see the screen reflected in that little window there, and that's running Legos. So Legos menu allows me to pick programs which are expressed as Java jar files, so it's an executable Java program. So I can execute this program. And as soon as I start executing it, what it's going to do is realize that this robot hasn't been paired with Salesforce. And it's going to go off to a service that I've hosted in Heroku to ask for a PIN number. And it's a random PIN number. And as soon as it displays on the screen, we'll get an opportunity to enter it into Salesforce. So the robot, from your point of view on the right, has already been paired. I want to add a new robot to this machine cloud. I'm going to call it EV2, EV32. As soon as I create that record, I'm running a small Heroku Canvas application here. So that's actually punching out to Heroku, waiting for the PIN number to come up on the screen. As soon as that comes up, then there's an exchange goes on between Salesforce and the robot. And for those of you that are familiar with OAuth, it's essentially an OAuth refresh token that's being transmitted to the robot. And that will allow us to connect to Salesforce. When that PIN number comes up and we enter it, the checkbox gets ticked in Salesforce to say that it's already been paired. So the next time I start the robot, it won't try this pairing process again. So we've now got a number up there, 9678. And if you keep an eye on this screen here, as soon as I click pair, 9678, yep, you should see the display change to say that it's starting the process to log into Salesforce. And it's updating the robot. As soon as we see that starting to connect to Salesforce, we can refresh this page and that checkbox will go to ticked status. And we can have a go at sending some commands to it. So what we've rigged up down here is a kind of system where you'll be able to see some of the commands that I'm giving it, and then I can press a button here, and my able-bodied assistant down here will be able to switch to show you what's going on the robot. So what I'm going to do is I'm going to start very simply and change the LED colors on the back of the robot. So I'm going to spin it round, and so you can see that when we switch over the camera. So you can see now we're waiting for commands. So the robot's ready to receive commands. And if I refresh the record in Salesforce, you can see that it's now ticked and it's paired. So I can start queuing up the first command. I've got lots of standard commands to move it left, right, backwards and forwards. And I can use the LED command to change it to green when I send this command. So unfortunately, you can't see me click save and it change at once, so you'll have to trust me. There's no smoke and mirrors here. So I'm going to press 1. And you can see the robot there. So I'm going to hit save now. And that's changed it to green. Don't know if you caught that. I'll maybe let me change it to red, see if you get a bit more contrast on the screen. And change it again. Does that change? Yeah, it is red. Those of you that can see down there, it is showing as red. So that's the pairing exercise. We've now made a connection with the robot. Before we go into a bit more demos of moving the robots around, let me just show you a little bit about what went on there and just give you a bit of an overview from an architecture perspective. So essentially what happened is we've got some custom objects in Salesforce. We had a Heroku application. We had the robot. And we had another robot. It was already paired was EV3.1, but I was pairing EV3.2. The pairing process started. There was a communication between Salesforce and Heroku. They exchanged the PIN number. And once we exchanged the PIN number, the commands could flow directly. So once we made that pairing process, the Heroku application wasn't needed anymore. It was purely used to make the connection. So looking at that in a bit more detail, the robot started up. We ran that Java program. It said, have I got the token? If it hasn't, gave me the PIN number. Then it waited for the PIN number to be entered in Salesforce. Once we entered the PIN number in Salesforce, Heroku app exchanged the refresh token. And we stored that refresh token locally on the robot. So the next time I boot the robot up, it'll reuse that refresh token, and we don't need to go through this process again. And eventually we started creating command records. So let's see if we can start moving these robots around. So the first command, I'm going to send it a little bit more adventurous this time. We're going to get it to move, rotate left. So simply change the command record that I'm looking at, and we'll change that to the screen so you can see what happens. So we're using EV2, which is the one I just paired on the left-hand side. And that's rotated left. We can get him to rotate right and move backwards. So what I'm going to do is make him move backwards, and I'll repeat this process so you can see what's going on the screen. You can see the robot changing there. And if I go back to the screen, those of you that can see what's going on the screen, I can now change the record. You can see that the response times in Salesforce are pretty reasonable. You know, the streaming API is as near real time as possible. Rotate left and rotate right. So we've actually got 2 robots connected here. So how do we control both at once? Well, it's as simple as using the list view in Salesforce, the multiple edit. I've now got 2 commands pointing to each robot. Let me just zoom this up a little bit. So if I wanted to control both of them in tandem, let's see if I can do this without, there we go. We would tick both command records, change the command to, let's see, what have we got over here, rotate. So we'll get them both to rotate left. And we'll select both records and hit save. And they both rotate together. So we can also change the robots to move right together. And this time I'll switch to the screen so you can see, I'll switch to the camera so you can see what's going on. And they both rotate. So what we can do now is start to program them. So at the moment, it's just been sending individual commands to them. So what if we want to send a single block of commands, get them to do multiple commands at once, kind of like a robot dance? So we've got a programs object here. Let me flip back to number 5. Let's create our dance program. And start adding some commands. So we'll get it to move left, save and new, and then we'll have it move right, save and new. So you can see it's very easy. It's one of the goals of the project to be able to just use the standard Salesforce UI. And then I have to be careful I don't get them to run off stage here, so we'll get them to move backwards 10 steps. And then the last command will get them to move back to their starting position 10 steps. Okay. So if we wanted to review that program, go back to the program, the related list shows us what's going to happen. It's going to move left, then right, backwards, then forwards. So to send that to one of the robots, so we'll choose EV1 on the far right-hand side. Again, I'll do it first in Salesforce so you can see what's happening, and then we'll switch to the cam and I'll do it again. So this time I pick the run program option. Rather than sending an individual command, I can pick the run program option. This number tells it how many times to run the program, so we're just going to say run it once for now. So that's performed that sequence of commands. Let's see that again from the point of view of the camera. So this time I'm going to actually have it do that twice. So I just change the parameter to say run the program twice in succession. So you can see it's executed that command twice. So that's a really easy way to program Lego robots. That's kind of the vision of the project, to allow us to create a stream of commands, send them to the robots, and allow you to create a community of robots. Using the pairing process, there's no reason why you couldn't perhaps expose this via Force.com sites or the Salesforce community even, and allow people to share in your community of robots. And of course, they could be anywhere on the planet with an internet connection. So let's just move through the rest of the deck. We've got some, for those of you interested in what some of the code might look like, I'm going to open source the code, but some of the highlights would be using regular HTTP code, and that's just accessing a Heroku service that gives us that PIN number. So earlier when we were pairing, it was getting the PIN number. That's the code it was doing. And most of the time, that's basically regular Java code. So the bits at the bottom are the lcd.clear. Those are unique to the Java library that's behind the Lego robots. And then we're waiting for the PIN. So again, regular Java code until we get the PIN number. When we get the OAuth token from Salesforce, then we break out of that loop and we're ready to start connecting. There's a small Canvas app that you saw me enter the PIN number into. You type that PIN number in, and then it sends that OAuth token back to the robots using the pairing resource, which is a little REST service that I wrote. When the streaming API is used, you subscribe to a channel. This is standard Salesforce use of the streaming API. You basically subscribe to the channel, and any time a message arrives, aka a command on a record on the command object, that gets sent via the streaming API. So we get the command, the parameter, the program to run, also the ID of the robot. And here's what we were using to move it around. Pretty straightforward stuff. Move forward, move backwards. You control the motors. There's 5 full motors on the robots. And it's pretty straightforward syntax, very similar to Apex, of course, Java and Apex borrows a lot of its conventions from Java, so it looks pretty familiar. So interesting evolutions of that code, actually. The very first time that I wrote it, it wasn't based on rotations. It just ran for 1 second or 2 seconds. But unfortunately, I found that as the batteries went down, it went even less time. So it now goes on rotations. So even the batteries are slowing down, the robot's slowing down, it still moves the same distance because it's measuring the rotations on the axle of the robot. So it's a much more reliable way of using it, even though the batteries might be slowing down. So if you want to give this a go yourself, it isn't particularly hard to get going. The hardest thing sometimes is getting the SD card formatted. Those of you that want to give it a go and happen to have an SD card with you, I can certainly help with that later this afternoon. There are some reasonably good instructions on doing it. The good news is you don't have to sort of damage your robot. Most of these devices you have to flash firmware and stuff. It sounds very scary, you're putting new firmware on it. What if I brick it and it, not to overuse the term there, but what if I damage the robot? And Lego won't be very happy with me. Well, the good news is you don't have to do that. If you put the SD card in the robot, the operating system just boots off that SD card. If you take the SD card out, you're back to your regular Lego robot. So make sure you get the SDHC memory cards. Those are the important ones. The XC ones don't work currently. And then the EDIMAX is a tiny, tiny little Wi-Fi adapter. In fact, if I just switch back, we might be able to sort of zoom in on that a little bit. You can see where I've installed it. So perhaps point it out. There it is. That's the little Wi-Fi adapter, and there's the memory card where it goes. So it's useful because it obviously doesn't stick out that far, so it doesn't kind of conflict with the constructions and robots that you're making. The Gripper robot is the robot that I've built the software around. So if you build a different robot, you might need to change my software a little bit. I chose the Gripper robot because it's got kind of quite robust for doing demos and moving around. There is the Walker robot, but he kind of gets a bit carried away and wobbles himself over quite often, I find, so it wasn't very stable. So yes, ultimately I will publish the source code. Time's not permitted me to do that at this point, but if you follow that repository, it's actually up there at the moment, then as soon as I push that code in there, you'll get hold of the code to do it. And you'll get the machine cloud app that you can install into Salesforce, and then install the Lego Mindstorms software, the Legos software on your SD card. And there's a wiki page that talks about how to do that and connect it. So essentially, run the Wi-Fi option on the menu, type in your Wi-Fi password, and the software automatically connects to the internet. So pretty straightforward. The hardest bit probably is going to be step one. But if anybody has any problems getting the memory card right, I'll be more than happy to help sort that out. And then ultimately connect the robots. You saw at the very beginning of the session, just run the EV3 Force jar. I'll include that in the open source repository as well, and how to get that onto the robot. Put your PIN number in, log into Salesforce, receive the PIN number, log into Salesforce, get the PIN number, and away you go. So I've got a few other ideas, visions of where this might go. You could potentially expose this via Salesforce communities, and we could start a whole sort of proper machine cloud where we're all sharing our robots and having them interact over the internet across the world. Could even consider an API. The Salesforce API does already give us a way of inserting records. That's already there. So you could have sort of machine cloud integrations by just using the Salesforce API to push commands in and then distribute them to the devices. That would be pretty cool. It's something that's readily available right now. You could even add other devices like watches, smart watches. Financial Forces has announced some prototype we've built around our ERP software using the Samsung smartwatches at Dreamforce this week, and time permitting otherwise, I was planning on making it controllable by the watch. It's easily possible with the APIs and the SDKs that we've got available to us. Phone support's already there. If you think about Salesforce1 Mobile, we could equally have been controlling the Lego robots through our Salesforce1 Mobile app when we logged into this org. Salesforce Streaming API does support generic streaming events. So those of you watching demo think, well, what if I don't want to create a record in Salesforce? What if I wanted to create a Visualforce page with the buttons on it to tell it what to do? That would be a useful capability, and there is a generic streaming API where you can send specific commands to the robot, not necessarily related to the database. So that's in pilot at the moment, but that could be another enhancement you could make. So that brings us nicely to the end of the session. We've got a few minutes for Q&A, and also just a reminder that I will be posting the deck and all the relevant information up on the chatter feed as well after this session. So we've got about a few minutes to take questions if there is any. There is a mic in the middle of the floor if you'd like to make your way there, and everybody else can sort of hear the question. Thank you.
So my question is, you have used Streaming API for the real-time communications. Can't we use other real-time based libraries like the Meteor.js or things like that?
Yes, you could use those. I use the Streaming API because it didn't require anything other than Salesforce. So the Heroku app I used was just really to get things connected. But after that, it's pure Salesforce. There's no additional services or technologies required. But you could have used that library equally if you wanted to create a Heroku kind of cloud for running the robots. That would have worked just as well, yeah.
Okay. My second question is, we are using the Salesforce here. Can't we use the communication that we are using with the robot without Salesforce? Like, it would be more like real time if we use, like, again, Meteor.js or other libraries.
Yes, I think it would. It would be more real time. The Streaming API doesn't do a bad job, but ultimately the Streaming API isn't guaranteed delivery. You would want an API if you were using something that was for actual mission critical solution. You would want something that was a guaranteed delivery mechanism. The Streaming API is good for building this prototype, but ultimately, at the end of the day, it demonstrates the technique reasonably well.
When you were putting together the program,
Yeah.
Where are the commands actually queued? Are they queued in the Lego brick, or are they queued in your code within Salesforce?
They're queued in the Lego brick. So once it receives the program to run, it'll download the program into the Lego brick and then execute the steps.
Gotcha.
The original Mindstorms had IR that you could use to communicate between the two.
Yeah.
What are the current capabilities?
You can use Bluetooth to do that, and also Wi-Fi. So these robots, what I didn't demonstrate actually in this session, I can demonstrate a bit more this afternoon, is I do actually have a command, a mechanism for forwarding, forwarding to robots here. So this field would say execute that command on this robot, but when it arrives, forward it to another one. So I could actually get them, and I was kind of doing a bit of a trial demo last night in prep for this, but I got both of them going spinning in loops and things, so I thought I'd better not risk it. But there is a technique, and of course that forwards it through the internet. They don't need to be tethered. They could be in completely different locations. But yeah, you've got Bluetooth connectivity, and that comes out of the box with the Lego software actually.
And then my follow-up is, can you presumably use the Wi-Fi to send information back up?
Yes, yeah. So I did create a sensor data object. I did demo it a little bit last year. Time wasn't permitting me to go into much detail here, but you can probably see some of the fields that I did. Yeah, I had a kind of category for the sensor, the ultratronic sensor, then the data, and then what robot passed it in. So it was able to capture that.
Have you tried to use some sort of artificial intelligence to create comments dynamically?
Sorry, what was the second bit of the question there?
To create comments dynamically.
Commands,
I'm sorry.
No, not really. It's an interesting thought. One of the things that opens up possibility here is any of the Salesforce technologies. So I'm a big fan of flow, visual flow, and flow triggers can be used. So you could potentially use a flow trigger when a command or some data is received to create a new set of commands based on some rules and some conditions, and then send those back to other robots. And that's just using Salesforce technology, the flow technology. So yeah, there's quite a few options. Obviously, you can use workflow, you can use Apex triggers if you wanted to, and build that knowledge into Salesforce. Okay, I think is that any more questions? Otherwise, I'll thank you very much and enjoy the rest of your day.